Section 4.3 covers all the different ways that we can factor quadratics. There's a number of different methods that we use in this section, so we split it up over the course of a few different days. Day one, we're going to focus on factoring out GCFs and factoring quadratics in the form ax squared plus bx plus c, notably that they have a leading coefficient in front of that x squared. To start, for every problem, when we look at it, we want to see, is there a greatest common factor that we can take out? Okay, is there anything that we can divide all the things in the problem by, all right, and factor it out to the outside of the problem? So when we look at number one, all right, we have a 2 and a 10, for example. Okay, those are both divisible by a 2. Okay, we also have x's in both. Okay, we have y's in both, and we have z's in both. Okay, so there's a GCF in this problem. Okay, the GCF of the coefficients is 2. All right, but there's a GCF of all these variables as well. And the GCF is going to be the smallest variable that exists in all of the terms. Okay, so the smallest x that we have is this 2. Okay, this x squared. Right, the smallest y is the y to the 5th over here. And the z's are the same, so that's going to be part of our GCF. So the full GCF is a 2 because that goes into both of these numbers. X squared because that was the smaller variable when they both had x's. Y to the 5th, z cubed. So our next step is to divide everything by that GCF. Okay, so these 2's are going to cancel. These x's are going to cancel. These z's are going to cancel. We still have y's left. We'll come back to that. Okay, over here, these y's will cancel. These z's are going to cancel. All right, these last two terms are going to simplify. Okay. Now, when we write our answer, okay, there's still things to simplify which we haven't talked about. Okay, so this can simplify, and these can simplify. Okay, but first thing that we write when we write our answer is that we write the GCF on the outside of the parentheses. It's like we're about to distribute it in. Okay. Now, when we simplify this y to the 7th over y to the 5th. Okay, remember your division rules back from Algebra 1. Okay, when we're dividing exponents, we're going to subtract those exponents, bigger minus smaller. Okay, so 7 minus 5, we get y squared left over. Okay, for this next one, 10 over 2, that's going to give us this 5 here. And same thing, subtract these exponents, 5 over 2 gives us x cubed. Okay, this GCF, like I had mentioned, goes on the outside. It's like we're distributing it in. Okay, if we did distribute it in, this whole thing turns back into what we started with. All right, number 2, look at all these coefficients. Okay, what's this? The largest thing that we can divide all of those by. Okay, it's a 3. Okay, if we look at all of our variables here, do they all have a's? Okay, they do. We look for the smallest a, which is a to the 5th. Do they all have b's? They don't, because this doesn't have a b. Okay, which means there's not going to be a b in our GCF. Do they all have c's? They do. We're going to take out the smallest c that we can find, c to the 5th. All right, so our GCF is this 3, the smallest a we have, the smallest c we have. Okay, there's no b because this one didn't have a b. All those get divided by that. Okay, cancel anything we can. C's cancel, A's cancel. Okay, nothing cancels in that last one. All these fractions are going to simplify. All right, GCF goes on the outside. 5, subtract exponents, a squared. B to the 12th is left over there. Okay, 10 when we simplify here. B to the 10th, c squared when we subtract those. 7 when we simplify those guys. A to the 5th, c to the 5th when we subtract the exponents. So those were GCFs. The other thing that we want to focus on this first day of section 4.3 notes is factoring trinomials. Okay, now, when we're factoring trinomials, we're doing little puzzles. We also want to start off with blank times blank equals. Okay, and we're going to write a number over here. Okay, and blank plus blank equals. Okay, and we're going to write a number over there also. Now I like to call this factoring method earmuffs, and that's because we start off by multiplying these two outside numbers. Okay, when we do that, I always circle them, I connect them, and it looks like a poorly drawn set of earmuffs there. All right, so 5 times 6 equals 30. We write the 30 in this first blank here. Okay, underneath that 30, we take this number in the middle, negative 17. So this is the logic puzzle part. We want two numbers that multiply to 30 and add to negative 17. Okay, so this you need to figure out on your own by knowing your multiplication tables. And hopefully you can figure out that negative 15 and negative 2 multiplied to positive 30, and they add to negative 17. All right, once we have those numbers, we're going to take this first term, okay, and we're going to drop the exponent. So it's just the 5x, okay, and we're going to put it on the top of two fractions. And we put each of these numbers underneath it, like this. Okay, and now we look to see, can we simplify these fractions at all? For example, this one, we can simplify. 5x over negative 15, we can make into x over negative 3, because both those numbers are divisible by 5. This one we can't simplify. We leave it just as it is. Okay, now we have everything to write our factored form, and it's just going to be this simplified version written as a parenthesis. Okay, so x minus 3 turns into x minus 3 in parentheses. 5x over negative 2 turns into 5x minus 2 in parentheses. All right, let's do another one. So start off by filling in those equal signs. Okay, so we have our earmuffs. Negative 21 goes here because you multiply those two outside numbers, adds to 20. This combination of numbers tends to throw you guys off more than any of the other ones, which is peculiar because it's probably the easiest set of numbers that we could have. We have negative 1, positive 21. Okay, multiplies to negative 21, adds to 20. Take that 3x, drop the exponent. Okay, put it over our two numbers there. Simplify anything that we can. So this is going to become x over 7. This one we can't simplify. So we have x plus 7 because it's positive, 3x minus 1. Okay, we could check these by foiling them out. So if we foiled these, we would have 5x squared, which is what we have here. Okay, minus 2x minus 15x would give us that minus 17x in the middle, positive 6. Okay, so you could always foil it to see if you got it right. Let's do another one. 2x squared minus 3x minus 1. Okay, so blank times blank equals negative 2. Blank plus blank equals negative 3. So the only two options to multiply to give us a 2, positive or negative, are 2 and 1. Okay, if we make one of these negative, okay, that's the only way we can get a negative 2. All right, but there's no way that we can make one of these negative and get a negative 3. They'd have to both be negative, all right, but that would make this into a positive 2. All right, this is can't factor, no solution, right, so we're done for this one. All right, lastly, there's one additional thing in this problem. It's the fact that there's a equal to 0 at the end of it. Okay, we do it the same way we did the other ones. Okay, start off by multiplying these two outside numbers. Just ignore the 0 for now. So blank times blank equals negative 36. They add to 5. Okay, so we're going to, let's see, 9 and negative 4 would give us those two combinations. That's 3x over 9, 3x over negative 4. This one we could simplify, x over 3. Okay, and it gives us this factored form, x plus 3, 3x minus 4. Now, the difference with this one is that since it's equal to 0, we're looking for solutions, not a factored answer. So what we're going to do now is we're going to split it up. Okay, we take each individual parenthesis and we set it on its own equal to 0. And now we're going to solve each one of these. So minus 3 over on the left side, plus 4, divide by 3. Okay, and we get our two answers. So we have negative 3 for our one answer, 4/3 for our second answer.